everyone, and welcome to the fourth session in the 5 steps, where we'll be considering steps 4 and 5 regarding the selection and integration of inkjet technologies as part of FuturePrint TechFest. So with me, I'm lucky to have guests from FuturePrint partners Phosian, Ricoh, IIJ, and Meteor. So that's Rob Carston.
Thank you.
That's Richard Darling.
Hello.
John Corral and Clive Ayling. And I am Mark Bale. So what we're going to do today is just basically be discussing the benefits that arise from some of what we've seen already, which is collaborative efforts of suppliers in the industry to helping people who are both already involved in the inkjet market and new to it, and talking around the topic of how you make the selection of different technologies. And for that, we have a range of different technologies that are represented here today. For me, I've got a background in ink, so I'll be kind of playing a role of having ink as an important component and using that as a discussion point for inviting comments from our panel as we go on regarding the products they represent and taking the benefit of their experiences over the last 20 years or so, I think we all share.
Yeah.
So in many ways, ink is one of the important technologies that underpins the performance of inkjet in industrial applications. But actually, we often think about ink and head together at the beginning of a process. So that leads me straight to my first question, which is for Richard. So Richard, when a customer comes to you, is it that they've already got an ink that they're thinking of using? Or do you have to help them find that product when you're trying to promote your printhead?
That's a good point. Sometimes they come and they actually assume that there's an ink for a particular application, and they've got in mind that they're going to develop something. They're racing into choosing a head. They might be choosing other things as well. We're all covered with NDAs, so we don't know who else they're talking to necessarily at the beginning. But there are certainly some cases where there's been an assumption that there will be an ink, and then it comes very much later in the process. There isn't actually an ink that can do all of the things they expected. So I'm right with you there that ink is half of inkjet, but it's actually more than that. It's very important to consider it earlier on. Otherwise, you could actually develop something that doesn't meet the brief. Different inks need different things, and if there isn't one to do the job that you want, then, like for example, drying, curing. Yeah. If you can't cure at that speed, then why do you need a fast head? So it's sometimes they have an ink in mind, but not always. And sometimes they think that they'll get one eventually, but they're too wrapped up in the hardware.
And so from my experience, ink is always the material if in industrial processes that really defines performance once it's part of the manufactured part, the thing you actually want to make. So I think you had a great analogy for that.
Yeah,
before.
yeah. So it's when grandma sends her little grandchild a present, then nobody's interested in whether it's DHL or UPS or whatever. Nobody's interested in whether it's a Mercedes Sprinter or a Ford Transit. Nobody's interested in it's white or black or dirty or clean or shiny or what colour bells and whistles it's got all over it. What they actually care about is what grandma's idea was for the present for little Johnny, and whether it gets there in one piece. So the chemistry is, in that situation, the important thing that's delivered. Everything else is peripheral, and we sometimes get a little bit wrapped up in ourselves thinking of our own importance when we're just the delivery mechanism.
Yep. So, John, you've got a lot of experience in dealing with different chemistries in a wide range of applications. Do you agree with those comments?
Yeah, very much so. I think the ink is really the key component in any new project, especially if it's a new application, new market. As Richard said, maybe the ink doesn't exist, and perhaps the customer doesn't really realise that. You know, he might be using a different technology, conventional printing, and he's just going to presume that some ink will be available, that we'll be able to find an ink that meets his requirements, that works on his material. It's not guaranteed. We have to find that.
So presumably there's a process that you have to follow in order to identify the right materials for any given application. Can you talk a little bit more how you do that at IAJ?
Yeah, sure. First of all, let's find out what the customer wants, so that the starting point is to understand his requirements, which is listen and then listen some more. Try and extract from him what his real goals are. Try and get beyond, I need this speed, I need this resolution, to, okay, what's your economic requirement? How much is this going to cost you? How much are you comfortable with? What are the regulatory requirements? Can I use a UV ink, or is that going to conflict with some regulation? So first of all, it's find out what he wants. Almost inevitably, then we go into print samples. Typically, we're working on new market, new application. The customer's not going to buy anything unless we can convince him, unless we can show him. So we do this we've got a fairly well-organized, well-defined process. We start out with what we call a customer assessment. We ask him to send the material. We'll try lots of different inks, find which ink seems to be working best for him to meet his requirements. So not just how's the quality looking, does it scratch off, but what other tests does he need applied at that point? Next step, we invite him in. This is really important. Before we realized that, when we were just doing postal samples, this is going back a long time, our success rate of getting a sale was tiny. It was something like 4% of the projects would you actually ever land. So we moved away from that. We invited the customer in for the second step. We think we've found the ink. We think we've got the correct ink. Now we need to show him how we make samples. It's interesting. They need to see that. They need to see the samples being printed. If they don't actually physically see it, they may have any kind of imagination, anything in their heads about what's really going on. And they don't have much confidence. But if they can come in, see the samples made, best situation is where he's pressing the button. He's actually making the samples. Mm-hmm. Typically after that, they might want to see some high-speed printing. So we might go into a roll-to-roll system and run at the kind of line speeds he's looking at. We do some demo there. Then you get into things like return on investment calculations, payback time. All of that works well. Then we, virus allowing, we will go on his site, measure up, look at his production line, look at what other equipment we need to interface to, where in the production process we would need to operate. And finally, after all of that, we're talking a specification and a proposal. So it's quite a long, multi-step process, and one I think is fairly well defined for us now.
So two things I'd like to pick up from that. One is just a comment, actually. I remember when I did a demo day at Sun Chemical, and I was using your XY200. It was amazing to see people's faces when you just took a UV ink, an everyday thing for us, and you made a liquid turn solid instantly using, say, Rob's technology. Yeah, and it's when you've got someone who's new to printing, using inkjet as a manufacturing tool, a demonstration can go a long way.
It's sometimes surprising. I mean, most of what we do is single pass. So the product's going once under the inkjet print head finished. And the number of people that will go, wow. And to us, of course, it's normal. It's every day. It's a bit boring. But something going under there in a fraction of a second, it really can make the customer jump. It's good fun.
So you mentioned UV inks more than once. Do you see quite a lot of requirements that you're still fulfilled with UV, or are you seeing a change towards more and more aqueous inks, for example, that we hear about?
Aqueous is definitely coming. Food packaging, decor, things like wallpaper. Aqueous is very much, I think, the trend. Still lots and lots of UV. It still dominates. But yes, there's a definite move towards water-based inks for things like flexible packaging. This is definitely coming now.
So talking about coming technology, Rob, you've got fundamental, well known for UV LED, and we were just talking about UV inks. Yeah. But actually, you've made recent announcements about stuff that's maybe more useful for water-based as well.
Well, absolutely. I know we're always trying to keep ahead of what's going on in the industry, and that's very much when back in 2004 we introduced the first industrial UV LED lamps. And that was at the time when UV was really starting to take off in terms of inkjet and looking at new ways of curing and doing more efficient processes. But we see that there are trends going forward in the future with aqueous-based technologies that we want to be involved in. We have certain platforms in longer wavelengths like 850, 950 nanometers, which are more in the near-infrared type technology, which are also solid state. So we're starting to see applications where we developed what we call an explorer lamp, which is a way for people to try and test a new technology. So we have a number of different wavelengths, platforms that people can borrow or even purchase if they want to do it for a longer term. But it allows them to try and experiment with the technology to look at ways, is it going to pinning? Are we looking at full cure? What are the parameters of the process? How do we need to evolve the ink design if we want to go down that route? So yeah, we're always constantly looking at different opportunities. We're doing just as much development work on things like UVC light sources as well. And we have, I think, from our perspective, we're kind of always working with the chemistry people, but we're also working with the semiconductor people. So we invest time and energy and support with semiconductor companies that are developing new and upcoming platforms in semiconductor technology. So we have that kind of side of our company as well as the chemistry side, and looking at how we can integrate all those different technologies to address, shifts in the market, whether they're towards aqueous or whether they're towards UVC, for surface curing and all those type of things. So yeah, we're constantly, that's all going on in the background all the time. And in the meantime, we're making plenty of UVC 395 nanometer light sources. That's still the dominant technology within most of inkjet printing and graphics and single pass, and whether it's pinning or full cure, that's, it's still a very, very important part of our business and will be for a long time to come.
Yeah, I think I used my first pinning lamp back in 2008 on a label printer, and at the time it was a fairly new thing, but it seems now actually has enabled a whole way of approaching integration for printers because of the form factor. And it's exciting to see if that solid state benefit can be rolled over into future machine development as well.
John was a reluctant advocate of pinning, if I remember. We had many a discussion about pinning, John, didn't we?
Pinning is vital in the right place, but it's when the customer just wants to put it everywhere that I get upset.
I know. But you're right. I mean, it's about horses for courses, and and I think pinning is a valuable function in terms of, especially in terms of print resolution. And so it's been important for that, and that's an important part of our business, as is the full cure side of it as well. But, we're always trying to enable and to keep up, because everybody wants to go wider and faster, it seems, all the time, right? So, we need to figure out ways of addressing that by building scalable light sources, wider windows, higher intensities, different wavelengths, air-cooled, water-cooled, so we can take into account different environments that people are in or space requirements. We've got some very small, really high-power lamps. We've got some big, low-power lamps. It's just always trying to meet the various different requirements that we have. I mean, one of the biggest applications we have is a very small 25 watts per square centimeter lamp that gets put into the hundreds of these printers that get made a month.
Okay.
Yeah.
Great. So, Clive, we just heard about the complexity of printers, but we also heard about the scalability. And so your products actually underpin a lot of what we see in the market, but we don't necessarily know it. Can you tell us a little bit more about how you help your customers, you may not be delivering an entire solution, but helping them develop these amazingly fast printers for the next generation of inkjet applications?
Yeah, well, the components we're talking about up till now have been physical things, but the electronics, okay, you need a physical component to drive the heads, but you need the software stack above that to do all the functionality that you need. And software people talk about that as components too. So if you want a high throughput, you've got to look at where the images are coming from, what do they look like, where the data sources are, how you're going to merge them, how you're going to rip them. And all of those components have got to be sourced and put together if you want to have a high throughput system. Do you really want to rip everything, or do you want to rip once and print many, or do you want to rip once for the background, print many for the foreground, where you're going to merge them? Starting off with a software basis which has got where you can add on top of that means that you can very often put a lot of that into a prototype. You can add some of these things later for sure. If the screening doesn't work, you can look again at the screen and change it, a lot more flexibly than you could say change the ink. Okay, I admit that. So you could say, well, it's less important that you get everything right the first time. But projects can fail early on because all those components haven't been optimized, and people assume that something else is wrong. People often they diagnose the wrong fault with inkjet. Okay. You build a prototype and it doesn't perform the way you want it to, and people say, oh, well, it must be, and then they randomly jump at something, basically whoever they paid the most to up to that point, and say it's their fault. In reality, inkjet is a fantastic thing, does fantastic things, but every single component has to do its job correctly. Each one of them has to be correct. And that could be the way it's ripped. It could be the way it's being dried. It could be the way in which the ink supply is pumping, or the filters are blocked. Or every single one of those components has to work. So the company that I work for, the Meteor company, we supply various of those components, and perhaps they aren't as basic as ink chemistry, but nonetheless, if you've got documents flying in and the encoder's jittery, you're going to get a bad result. It's not the ink's fault, it's a bad result. It's because we haven't set up the software to cope with a jittery encoder well enough, for example, or maybe you've got documents coming and they're randomly positioned with respect to each other. Again, you can set up the software so that occasionally the signals come in to start a new document before the last one's finished or something, and then one head out of 10 seems to have that fault, and you go, well, that head's broken. No, it isn't. It just happens to be the one that's slightly further ahead than all the others, and that's why it catches it first. And so these components, although they don't appear to be as fundamental as the chemistry or the physics, actually they can completely confuse an integration process if they are catching the wrong thing, and you don't diagnose that correctly. Of course, the converse is true as well. I mean, I've had boards returned, electronic boards returned, saying it doesn't seem to work properly. Half the head isn't working, and then you find out later on that it's because they've got a slightly blocked ink supply, and when they print at high speed, there's not enough ink pressure anymore at the head, and half the head stuffs. It's a filter that's wrong. It's not the head, it's not the ink, it's not the electronics.
And certainly that's a common story for me, consulting as I do with people who already have machines and trying to figure out what's gone wrong with them when they have issues like that. And filter blocking and the ink-related failures in systems must be something that's quite a familiar challenge for you, John.
It's very much part of the testing we do. Any new project, new application, we've already said it's probably going to be new ink. You've got to test the ink. And again, a bit like how we handle a new inquiry and getting through the print sample process. A new ink, we've got a 7-step, sounds like Alcoholics Anonymous, but it's not. We've got a 7-step test process. And, by the end of that, we've got confidence this ink's going to work. But the last test is actually we put it in a machine and run it for 2 solid weeks. Everything else is working up to that. But in the end, you've just got to be sure that it works, and that's the best way to find out, to prove it.
Okay. So, Richard, I would like to come back to you, because we started out talking about how printheads are, in combination with the ink, are a very important part of how you integrate a system. And we talked about having an ink in mind. When you advise a customer what printhead is actually going to help them, how do you go about what questions to ask? How do you just start that process?
It'd be nice to think that everything was in a formula and you could follow a set process. And John, I admire the way you've done that. But I bet there's some exceptions. There are always exceptions, and I think if it was that straightforward that you could ask that question, get that answer, and then you could plot your path through this journey and come up with the right route, that would be great. It's not like that, and there are so many of these variables are interrelated. I'll bet everyone here has been dealing with problems that are outside of their real scope. Like Clive, you mentioned about printheads, half of it's not printing, and then it's an electronics return. Or it could be, this printhead doesn't work in that, and then it's actually something to do with something else. We all try and fill in the gaps, and we all turn into jacks of all trades, as our customers have to in the end as well. But but it's not so straightforward as just sort of saying the answer to that question is that, so therefore that. I think you have to go back before, and I think it's often talked about. You go back to first principles and mention of what a customer wants or what a customer needs. They're often not that straightforward, because what they think they want is not necessarily what they want. So, I'll give you an example. Somebody says they want offset quality, then you should use offset. That's a technology selection. Sometimes the selection should be not inkjet, and I think for some of us we ought to be straightforward about that. Digital doesn't replace everything, but then there are some ideas that need a little bit of refining along the way, without just sort of accepting that that's what they're trying to do. Choosing a printhead, the chemistry, as we've talked about, is important. It's fundamental. If you go for certain types of head, then you're limiting the chemistry window. So therefore, you have to figure out what job it's got to do on the substrate. What little Johnny's getting from his grandma, in other words, to use my example. But if you know what it's got to do in the end product, then you can look at the options for the chemistry. When you've looked at the options for the chemistry, that automatically rules out certain heads. Then you can look at the process, the place where the ink jetting is going to happen in that process, and there are some it speeds, feeds, materials effectively, and then it's the end product. What's it got to turn into? Does it actually need to be viewed under a loupe or a microscope, or does it need something is it a billboard, for example? So appropriate imaging, appropriate fluid deposition for the function, without getting into the technical game. And the less demanding you can make it, the more reliable it can be. That's my premise.
That's a good one, yeah.
Yeah, I think that's probably quite a good rule generally, but it certainly applies to inkjet integration.
We don't always follow it though, do we?
No, not always. But then if you want to make a system that's reliable, sometimes you're using clever software to cover up things that are more difficult to accommodate in manufacturing.
I mean, you can make physical nozzles to be as precise. The cutting edge is pretty precise. The actual shape of the nozzle, the position of the nozzle, the direction of firing, all of those things have tightened up over the years. And maybe people who had even one print head of a certain type, called A or B or C, 5 years ago it was different. So all of that has tightened up progressively over time. But still, we would rely on some of the things that the software brings in, Clive, to actually create the end effect, because there are some things that you can do with software that you can't do with mechanical manufacture. And we talked about pinning as well. If you pin at the right time, then you can get rid of some of those density issues that come as a result of blended colour and time on substrate before curing. So it is a combination of all of these things.
Yeah, despite John's remarks earlier, I was one of the first people to put pinning after C, M, Y and K. But it does come with its challenges. We're always in a process where there's an advantage, there's a potential disadvantage. In pinning, there's an advantage in controlling bleed of a UV ink on a very spreading substrate. But there's also a disadvantage of maybe overdoing it and creating not enough drop spread to give you the right line width or barcode readability.
Which then puts up the cost of the ink. You end up putting more ink down.
More ink to get the same colour intensity, therefore the cost of ownership is higher and it doesn't meet the
potentially
economics.
Blockheads if you don't do it properly. So there's a lot of issues around all these things.
And I think what we identify here is the strong theme throughout the TechFest event is that the collaboration between suppliers is very important to iron out these wrinkles and mean that the customer gets to where they want to be faster. Would you agree with that, Rob?
Well, absolutely. I think also that's fundamental to the whole success story of Cambridge, really, and why Cambridge is one of the world centres for inkjet technology. Because there is so much collaboration. You can drive around Cambridge in a day and pick up almost everything you need to build an entire inkjet printer. You got people like John with their fantastic expertise in putting it all together, Clive with their software, Richard with their heads, us with our light sources, and there is that huge amount of expertise in this area, but also fantastic amount of collaboration between people, just willingly all working together to deliver world-class solutions. And that's quite unique. I don't think there are many industries really working like that together.
Yes, and I think in terms of collaboration, when you have other things that come out, the importance of support as suppliers. So supporting your customer through that process. So what kind of things do Rico do, for example, if your customer is having difficulties? Because you've now got an excellence centre in the UK where you can help them solve problems related to their use of your printhead, right?
If the customer's got a problem, then we tend to walk away. No, that's a joke.
Yeah, really.
Just make
You
that
had me
clear.
there.
No, I think in some cases, if something goes wrong, then it could be that maybe we've got it wrong ourselves. So there's a lot more proactive work that can go on to make things more reliable. And I think, you can't expect customers to cover all these bases as part of a complex project in pulling various technologies together. So the more we can do to interact ourselves and do proactive work. And I'll give you an example there. In Telford, at our Global Inkjet Technical Centre, that's the application centre for the Rico industrial print world. And in our laboratories there, we actually... We're open. We work with the major ink companies to pull inks in to try and develop things, inks and primer systems as well, to pull things in so we can do the testing up front, because the ink can often be a rate-determining step in the whole project, and it can often be where the problems come. You mentioned things like half a head's not jetting. It could be a filter blockage, or it could be a gassing issue or retained gas issue. There are all sorts of different things. And if you can understand the characteristics and behaviour of the fluids and how to manage those characteristics, then you can get further along the line. So some of these problems we can foresee, and we should be able to, for all this 20 years of experience, we should be able to foresee a few of these things and overcome them in advance. And I think maybe, it's moving out of that early stages of maturity into a more mature field, so that people should have greater access to all of those things up front.
Okay.
That's our way through it anyway.
And in terms of delivering a finished product that's intended to make a print, John, I guess you can concur with Richard's comments.
Yeah, it's not... So, I've talked about samples, I've talked about ink tests. If we're delivering a finished working print system, the FAT, the factory acceptance test, is really important. So we think we know exactly what he wants. He's agreed to a test specification, how we're going to test it when it's finished. Generally, perhaps his application's a conveyor belt line or something. Okay, I can't simulate that very well. We'll agree to put it on a high-speed roll-to-roll system. We'll print his image at full speed, at full density, and we're going to run that for some hours continuously, top speed, make sure it's reliable. So testing the system before it ships is really important. We like to repeat the same test after install. So, the customer will come and watch the factory test. Then we do a site test. We'll install it and we'll run the same test again. Everything's good, everything's happy, he can sign it off. If it goes wrong after that, sometimes we didn't really understand some detail to begin with. And this is something that comes back to the listening right from the start, trying to grasp everything about it. So I think sometimes the customer's so into his own business, his own technology, he doesn't tell you something. Mm-hmm. It's obvious. Everybody in that industry knows, you need a Heidelberg creaser cutter, and that's where you put the inkjet. Yeah. What does that mean? Do we know what that thing looks like? Do we know all the ins and outs of it? Do we realise that's a Siemens PLC that's controlling it and it's going to do this every so often? So sometimes it's trying to get out of the customer. Sometimes it's just experience. If you've done it before, you stand a lot more chance of actually understanding the little wrinkles, the little problems that are going to appear, and then being able to prevent them for the next customer.
Okay. And Clive, I suppose that once you're delivering hardware into a printer, and maybe it's a more experienced OEM, it doesn't mean they know how to solve every problem. So is it the software that from your sister companies that's really helping enable solving some of the issues like reliability and jets out and stuff like that?
Yeah, well, one of the unusual things about a software-enabled product like Meteor's Electronics is that you can actually change the functionality after it's installed, even after you've shipped, even after it's been used for 5 years or so. A problem that comes up then, you can still do something about it without having to change the physical product. You can look at the way in which you handle the data and you can change it. I remember, for example, we had a customer who didn't appreciate that his cutter, which was a mechanical cutter, would get larger during the day when it got warmer. So the pitch between cuts would change. Okay, you don't just give up at that point. You can, with software, you can just write some more software. You can write some software that says, okay, well, the resolution is going to get smaller during the day now, so that it stretches to match the length of the cutter. And you can write formulas and things, which we did, in that case, to make it so that the image now continued to track the cutter length. So it is a little different from some components. It's a really adjustable component, and certainly when it comes to print quality, we've had customers build single pass. There was a big wave a few years ago. You might remember single pass textiles. Everyone thought it was going to take off and rule the world very quickly.
Not everyone.
Not everyone. Perhaps some were much wiser than others, probably. I'm happy to go with anyone who's enthusiastic. And we had to put quite a lot of effort into trying to work out how to make how to improve the quality of images. So people built a machine. It would run the test image, like, the one that you tested for FAT and SAT, but then the customer would then try other products they want to print through it and say, it's not doing this one as well as the conventional one does, so we can't use that image. We can only use these. And I remember we had one customer who said their end user was only getting about 50% of all the images they wanted to print digitally. They could actually do so at the quality acceptable for sale. Now, we spent a lot of time imposing print quality improvement software on top of what they already had. And eventually we moved that from 50 to about 80. No, it's not 100, but it was a big increase if you say they weren't able to run the machine full time up to that point, but then they could, with 80% of images acceptable, they could do. So, it's quite an adjustable component, is what I'm trying to say. And the problems, the customers don't always aware that they have that problem. And certainly they're unable to explain it the very first time they come across inkjet. They don't say, here, this is the hardest image, this is the easiest image. They're naive about that bit. And to some extent, even we are, we may have supported a couple of hundred customers in a lot of different industries, but there's still something new comes along from time to time that we haven't seen before. Or that we haven't had a chance to tell the customer because he hasn't told us it will be a problem in his application yet. And that's when you have to, debug it after sale, if you like.
Clive, I will say, though, if you don't mind, that there are some... This gets into another area that's quite important. You say it's an adjustable component, and in Meteor's case, it actually is, because you actually offer that support and close contact with those projects.
We do.
In many cases, you can buy what's seen to be an equivalent component, which is not so adjustable, because of the support that comes with it, or no support that comes with it. So you can get an off-the-shelf standard product, but it doesn't. The whole package isn't like you've described. Mm-hmm. So there's some value in having not just a product, but a sort of knowledge base that goes with it. And I guess that applies to curing or printing systems in general, which I think is interesting. It's not just on the price for the apparent product. It's actually everything that goes with it.
And I think that brings us nicely to talking about return on investment and cost. A lot of the issues with introducing new inkjet applications against offset, for example, is that the ink can be more expensive. But actually, the value isn't just about the consumable. The value is about what you can bring a business in terms of flexibility. It strikes me, just as Clive was talking, Rob, that one of the benefits of your technology is that actually there's a fair ability to do retrofit should you find a power isn't high enough at the point they designed the printer, for example. Have you ever had projects like that?
Yeah, well, certainly, where people start off down a route and then they get to a point where they just can't get to the speed they require, then we can look at, shifting to a more powerful light source, absolutely. Or sometimes just changing wavelengths as well can help the situation. So, yeah, we're always looking to help, and we do retrofits onto some machines. Certainly we take like screen printing technology or inkjet systems and convert them to LED technology. That does help. That does happen as well.
That's great. I guess in those, there's sometimes a bit of a chemistry limitation as to whether it will work with a wavelength. But
chemistry is very much the backbone to it all, and sometimes for us it's frustrating because we get people asking us to go, oh, we just need to cure this at 150 meters a minute. And I was going like, well, you need to tell me a little bit more, and then you get some vague chemistry sheet saying, oh yes, it cures with UVA. And it's sometimes difficult to get information, even though that ink has been tested and developed with quite often with our own light sources in a lab somewhere, wherever, major ink manufacturers. But actually, sometimes to get the actual information in terms of, so that's going to change, with all this, and you get lots of weasel words at times, which doesn't really pin down how the ink performs. And that can be challenging for us. So we might end up having to say, look, our best guess based on our experience, and this is what kind of like Richard's talking about, is knowing, this type of substrate, it's that type of ink. We've got models that we've built over time that we can look at and say, well, yeah, we probably think that this is probably the best place to start.
Okay.
And that comes from experience and knowledge and 20-odd years of making these light sources and being involved in lots of different projects. And that then we say, okay, look, here's a light source. We have I think about $2 million worth of demo lamps that we lend out to people to help them test and develop their processes. And then they refine it and get it right. And then off we go. And then it's fine. And then, John does a lot of that in his processes, and I guess, Clive, they're also, I'm sure you're, lending software to people to develop it so they can build their processes, and I'm sure, Richard, you do the same, don't you? We lend people our technology to help them make better decisions. And then we say, okay, if that doesn't work, here's another one, try this one, or try turning it up or lifting it up or moving it along a bit further. And again, it's like you said as well, we develop some knowledge in chemistry. We develop knowledge in electronics, semiconductors, about handling mechanisms, about light diffusion inside equipment, about air currents and handling and temperatures. And, there's so many things you start to take into account when you're looking at all these different solutions. And we all are, like you said, masters of different technologies. And we know a little bit to be dangerous, I guess.
In that case, I must be very dangerous.
Yeah. Most dangerous man in the room.
So I think actually we've done a good job of covering the subject matter today. So I'd like to thank you all for your input. What it's good to see is there's so much experience to help customers who are looking to do inkjet. So people watching this event should be able to see who the people they need to talk to are for their specific applications or their specific ink needs. And thanks very much for your input. What I'd like to point out to those watching is that each of the speakers, I hope, should be available after the session in the Remo session so that you can track them down and talk to them in that networking session and ask any questions that may have come up. But there's a chance for you each just to give a final summary remark on the topic of inkjet selection and integration, if you'd like. So I'm not the last one talking, because that would be bad.
Yeah, I mean, I'm just saying it's an industry that we're very glad to be involved with, and we've sort of been there since the early days and been watching the industry grow and thrive and just becoming more and more dominant within the whole print industry, and it's an exciting place to be.
I think that during this period, it's actually, the last 18 months, it's actually shown that there's some fragility in the way that things have been done. And as a technology, digital print, not just inkjet, but all forms of digital print, can actually do things differently. And in the period before this latest virus era, there were lots of people who were trying to do things that they could do by analog, by digital, but exactly the same way as before. And I think that maybe that could be slightly different afterwards. Maybe it'll go back to what was normal too readily. But I think inkjet does different things, and it does them differently, and that applies from chemistry all the way through to the finished equipment to do it. Speeds and feeds, and whether you do it in this place or that place, is a whole supply chain, a whole manufacturing chain. So I think that there's plenty of technology. There are plenty of technology suppliers, and often we play trump card specs to pick out the one that might seem best. They're all interrelated, and if you get any one of the responsible suppliers, then you should end up with something that does the job reliably.
Yeah, I think following Richard's point, some of what we've been talking about in this session might sound a little bit scary to somebody listening. We're talking about the unknowns, the inks, the lamps, the electronics and software. I really want to say that the risk is way, way lower than it ever used to be. If you go back 10 years, you could end up buying a machine that wasn't really suitable for the job, mightn't be very reliable, didn't work well with a certain ink. It's not going to happen now. Doesn't really matter whose printheads are in the machine. You know, professional suppliers know what they're doing. They're going to test things properly. They're going to make sure it works properly. You will end up with a system that does the job. And it's economic. It
Makes sense.
Yeah, it makes sense. It's not going to cost you more than you thought it was going to be. We've all got, you know, different machine builders are good at different markets. We've all got portfolios, if you like, that we know very well and we're really good at. We're all growing those. We're all moving into new applications and new markets. But I just would like to reassure anybody watching this, it's not scary, it's not risky. Nobody's going to, I think, BS you or tell you something that, you know, isn't exactly true. The industry is maturing. Products are becoming far more predictable and stable. To be honest, when we sit in our R&D, our engineering meetings, we talk about the future. We actually talk more about software. The actual hardware, the ink, is getting really far more reliable and predictable. The future for us is going to be more about the user interface, connecting to data sources, how to ensure that, you know, you're not losing the data in some way just at a critical point. So that was really what I want to say. Things are maybe a lot more comfortable than we may have indicated in this discussion.
Thanks for that. Clive?
I think John said a brilliant answer there, actually. That was absolutely perfect. No, you're right. The 20 years I've been in this industry, things have changed. And I think you're right. The emphasis is now looking at a lot more, the GUI, the way in which you interact with the stuff. It's the way in which the images are going to flow to your printer. The risks, actually, in selecting ahead, okay, there are still always going to be confusions about, do I want this resolution or that resolution? And those issues aren't going to go away, but they work. We've had a couple of decades now of really good progress in our industry. And inkjet is working in so many more markets than it used to, successfully, profitably, not just as a demo machine that people might, they invested 5 million to sell 2 machines worth 500,000. It's actually working profitably in loads of different industries now. Profitably. The S-shaped curve is off the bottom, and inkjet is growing well. And of course, there's going to be more progressions in technology, of course, but we've overcome the basic ones. I think reliability is doable now. Many different ways to make it reliable. Everyone's worked on that bit. Print quality, I say, it's not offset; it's digital, but the digital print quality is accepted in many different markets now. And what we're looking at now is talking to it. How do you communicate with it? How do you do? How do you know what's going on in your machine? How does it talk to the rest of the factory? For example, the smart DFE that we launched recently. This is the kind of conversation that happens now because the technology itself, in most of these areas we're working in inkjet, are done. There's still going to be some bleeding edge in some additive manufacturing areas and things like that. But that's the fantastic thing about inkjet, actually. It can be always attacking a new area where it's immature. But there are loads of mature areas now, and that's terrific. I mean,
So, thanks, Clive. And of those final remarks, we have it from the experts that selecting and integrating technology is something that they know how to do. So come talk to them. And thanks very much for your attention.